So, what are we playing with today? We are playing with arrays, right? That's what we did last time. We are going to do it again and again and again. What is an array? It is a collection of things. It's of a fixed size. And the elements that it contains are of the same type, right? We can use these square brackets to declare arrays. We can use them. We can use the new operator to allocate an array in memory to create an array, and we would use the square brackets to decide how many do we want.
I got a question on that one. Sometimes I've seen after the type, they put the square bracket before the name.
Yes.
Which one is the proper way?
This is a horrible problem that comes from C. It works both ways. And so either way works. Depends on how you think about it. Many people like to do it this way because it looks as if how you're going to use it. Many people like to put it the other way with the square brackets right after int instead of right after the variable name, because that would be, this is the type. The type is int array. So just like the type is int, now the type is int array. But then you need to remember that you can't do it on the other side.
Yeah.
They're both acceptable. They both work. Some people will have a very strong opinion one way or the other. I don't terribly care. I would not even remember which way. You need glasses. You know that, right? You're squinting.
I know. I'll get something.
I wear glasses, so I know. You can, yeah. Only when you are creating an array, you can use the braces and put the elements in commas. This is only when you are initializing an array at the time of creation. It doesn't work. It's not an array constant, like quotations give you a string constant. Please note in Java 8. Arrays have a property, length, which gives you the number of elements in the array. Let me see. Java arrays.as. There is actually, let's see, list returns a list. Never mind. There's a bunch of things here, and we're going to do binary search. There's the arrays class has a bunch of utility methods for arrays. We access elements in an array with the square brackets, like in this case. And the first element of an array is the element number 0. We can pass arrays as parameters. Arrays are objects, so you can't change the reference, but you can change the content of the array. We have a pretty for each loop. Yes, sorry. If you say int square brackets a, whatever changes you make to a have no effect, right? That's the reference that you got passed. But if you do a of 0 equals 3, then that can be observed outside. So you can't change ARR, but you can change the elements inside ARR. Um, we talked about array of objects, right? There's nothing special about them. And you can have arrays of arrays, right? An array is just an object, so you have an array of arrays. This is almost a matrix, except that each array is independent, so they could be of different sizes. Unlike a matrix that has to be rectangular. We'll see, yeah. Kind of our standard patterns are do something with all the elements, print all the elements, do something to all the elements, actually change the elements, and use an accumulator. And we'll see min, max, and sorting. Do something with all the elements. Well, our example was printing, right? Did we do some? We did print array. We didn't do some. Yes, remind me. I was looking at them and I have them under a horrible folder, but I will add them. To remind me, I will. I was trying to do it before class, but then I looked and I got horrified at myself. I need to move them around and change all the names and stuff. Let's do int add, or let's do double. So we start doing double add all. How do we add up all the elements of an array? This is doing something with all the elements, right? You're not going to change the elements. Yep. We'll initialize a sum. We do a for loop, right? Let's first do this loop. How do I get the length of the array? Mm-hmm. Array.length, right? It's like an object, so. What do I add to sum? ARR of I, right? Does this make sense? Now let's do it with a for each loop, because these loops are ugly. Since I'm going through all the elements in the array, right? I don't need to iterate over the indices. I can directly iterate over the elements. Sorry? This, you are creating a variable that lives inside the for loop. So you need to define the type, give it a name, colon, and then the array. And this will be the type of the elements of the array, right? And Java 8 doesn't have type inference. So you have to repeat the type, even though Java knows what the heck the type is. But
so this is going to be increments in each array.
Inside, right? D is going to take all the values for all the elements in the array. It is basically the same loop, right? Look at it. Now, So this is what the loops look like, one next to each other.
These two is exactly the same.
They are exactly the same, right? The first one is iterating over the indices and then using the square brackets operator to get to the element. The second one directly goes over all the elements.
Doesn't that length need like parentheses?
No, because it's an array. Length is a property.
Oh.
You need to memorize that stuff because they are all different in different languages. And they're different within Java.
So it's not a method, it's a property.
I mean, in strings, it's a method, but in here it's a property because it wouldn't be confusing enough if it was the same.
So it's just like it's an int value.
It's a field of the array object, like x in point when you have a point p of x.
Okay. But normally to get like for an object to get like one of its variables, you still need like a getter method.
Sometimes for points you can use get x, but you can also just directly access the x,
So you could just
P
say
dot
like
x.
p.x with nothing.
Yes.
Okay.
which we did for points.
Okay.
So in this case, it's a public property that you can't actually override.
When can you not say like object.x or something like?
It depends on what the object defines. If when defining the object they say public x, then
You can
do
always do
x.
that. Okay.
If it's private, then you cannot do it except within the methods of the object, and within the method you can do it.
It has to be a public variable.
Yes. A public instance variable. Length is almost like a public instance variable. It's special because arrays are special. And you had a question.
That means that D is all the elements.
Yes, D is going to successively get all the elements, right? First it's going to get the first element, then the second, then the third.
With that statement, sum plus equal to D.
I'm adding the elements. Since D is going to take the values of all the elements, at the end I'm going to have added all the elements in the array.
So all the elements are adding in the for loop.
This for loop for double D colon ARR, right? What's going to happen is it's going to execute and it's going to evaluate the body with the first element in the array, then the second, then the third, then the fourth.
In the sum.
Well, and what I'm doing inside is add that element to the sum. Right? I could print it, I could send it over the network, etch it in stone, whatever I'm doing with it, that's
What is exactly D? You just declare the array.
D?
You give it D.
it's just a variable that lives inside the loop. It's what I'm gonna call the elements.
Okay.
Right? In fact, I normally do. I tend to call them element. It's just a variable name.
Okay.
It's what you're gonna use to refer to the elements inside the loop.
For the second format, I forget what you call it again.
A for each loop.
A for each loop. You can't modify it to be like anything else. Like if you, instead of plus plus I, you had like I equals I plus 2 or something.
No.
So for each is just always just plus plus.
For,
There's no
for
other way to go
exactly.
around.
A for each is just gonna go through all the elements in the array. The other one is slightly uglier, but it gives you more flexibility. Yeah, you could add up only the odd elements in the array, or the odd numbered elements in the array, or something like that, right? Which you can't do with the for each, or you'd have to do painful things to do it with a for each. Does this idea make sense? Leave it like this. So what do I expect to get out and start to print? 6.6, right? Makes sense? Cool. I could also do stuff to all the elements of an array, right? And this, I'm gonna multiply every element by a given value, right? What can I do? How do I do this?
Use the same method.
I could, let's see, it should work with a for each. What goes inside the body? What? MUL?
No, first you gotta declare product.
What's, okay, so double product?
It's gonna be above the, it don't matter where.
Sorry?
You gotta be above, move it above the for loop.
Why? But that's okay. Yeah. No, I'm trying, no. This is multiply each one of the elements by that value. I'm gonna change the elements. If I had 1, 2, and 3, I'm gonna have, and I multiply by 2, I'm gonna have 2, 4, and 6. Sorry.
Okay.
Well, we're going to say that like
So-
r dot I is equal to r dot I times value. Or yeah, not dot I.
Almost.
R.
Almost. I'm doing a for each loop, so what do I call ARR of I? If I had a for loop that had int I equals 0, I less than length, then I would use this thing. In this loop, what am I calling? What am I using instead of ARR of I?
ln. So not each side.
Does this make sense? Or
We thought you wanted to multiply all the
yeah, I'm sorry.
by each other.
So, oh god.
So is it always better to do that instead of like for the other one? Like, would there be a time when it would?
Which one is prettier? Which one, right? Why would you choose this one? Look at this line versus this line.
It's more simple. I mean, I understand, but would there be a time when it wouldn't?
When
The same,
when what you are doing is not where when what you are doing is not multiplying, it's not like multiply odd numbered. So I need to multiply only the odd numbered elements, right? Can I do it with this? It's gonna be a pain. I can do, right?
You have to add like.
I can do boolean is odd equals false. Is this better? No, this is ugly as hell, right? So instead of doing this, I do well, start at 1 and go. So I only do the odd ones, right? The odd numbered elements. I would rather do this than that other horrible stuff, right? So when what you're doing is not going through all the elements, then you use a for loop with indices and go figure it out. But many times what you're doing is just going through every element. So you just go through every element. Does that make sense? I need to print array. So now I can do set of at all. So now, what would this do? Convert those into 2.2, 4.4, and 6.6, right? So when I print it, that's what I would get. I multiply the odd numbered one by value. So which ones get multiplied?
Yes, 2.1. Oh, 1. So 1.1.
What's the first element of an array?
1, oh, 0. Oh, so you only multiply.
So only the middle one, which is 1, which is number 1. The other one's 0 and 2, and 0 and 2 are even.
Oh, okay. This is gone by array or inside the.
It's odd numbered.
Odd number of the array location
Yes.
or inside the array?
Numbered means the array location, right?
Of the array location.
As opposed to the value or the,
Okay.
right, the number.
Doesn't it start at 1?
No, never. Starts at 0. Well, it starts at 1. It skips 0, right? So it's not going to do anything to 0.
Okay.
Oh. Multiply by value didn't work. What did we mess up? Oh, that's good. There's another reason for doing this. It doesn't let you assign to the element. You cannot assign to that variable. You're not changing the element when you do. So we have to do it this way. So also the for each loop can only, right, right? You cannot modify the elements with a for each loop. Does that make sense?
Wait, why did they not all get
Why?
multiplied?
Because when that becomes a different variable, so when you assign to it, you are not actually changing the element in the array. You're changing your variable. We had it like this.
Oh, you didn't.
This,
That's the previous
that's the-
output. Oh, okay.
yes. This one,
I thought that was the new output.
this was the new output. When we run it again, like this, right? With lm times equal value, it doesn't do a thing, actually. We print 1.1, 2.2, and 3.3.
Oh, we're only looking at the first one. Okay.
Yes, the first one didn't change a thing.
Well, why did they multiply the first one, 1.1?
This one, right? That lm is a different variable. When you're assigning to it, you don't change the actual element in the array.
Okay. No, after you changed it, the first array was still 1.1.
It's 1.1, 2.2, and 3.3. After I'm done with this, this multiplied by value did absolutely nothing.
Yeah. Well, let's change it to the regular kind of for.
Because, right, this is changing, is not changing the element in the array. You cannot use a for each loop to change. So if I change it to this kind of loop, and all I really need to change is
Plus, right?
and start at 0, right? Now it's going to work.
Okay. Oh, first you start from 1, it's get the 0, so it didn't multiply the 0.
Now the
Oh,
other
I
one,
see that.
right, is now multiplied outnumbered by value, skips this one, doesn't do anything to it, multiplies this one by 2, and then doesn't do anything to this one.
In math, 0 is considered to be neither even nor odd.
No, in math, 0 is odd, 0 is even.
0 is even.
Well, I don't know. There is no, in math, every book author can define whatever the heck they want, but usually 0 is even. Google it.
Google agrees.
Prove me a liar.
Google agrees.
I bet you that there is some books in which they will, for some,
Yeah, some books is even, some books is
neither even nor odd. It's kind of depends on what they're defining and what's more convenient. To me, it would be even, but it's stuff like, usually math goes by logic, right? Usually math, they don't do exceptions, so it makes sense.
Well, for the
That is even?
factorial, they define 0 factorial to be 1.
But that's perfectly logical. The one that is not logical is that 1 is not a prime.
Yeah, that too.
That 1 is not a prime. Why? Because it's useful. Because I need the concept of all the prime numbers except 1 for talking about stuff like prime factorization and things like that. So they just say, oh, by convention, 1 is not prime. Yeah. Usually the conventions tend to be taking the definition to the letter, lawyering the definition. But anyway, so now let's do some mildly interesting stuff, right? We did min. How about sorting? Can we sort an array? Let's sort arrays of ints. void sort. How can I sort an array of integers?
A lot of different
Very
ways.
carefully. A while loop that does what?
Basically, you set it to.
There is a bunch of simple, sucky ways to do it. The one that I like the best is it's called selection sort, I think. Find the minimum element of the array, put it at the beginning. Now find the minimum of the rest, put it at the beginning-ish. Now find the minimum of the rest, put it at the beginning-ish. Does that make sense? Insertion sort is slightly more painful, and actually bubble sort is not that painful. It's just not terribly. It's pretty, but not useful. So let's do selection sort. What do I do? Well, what I do is create I'm going to call, this one is just going to call selection sort. Then we can define other sorts if we want to, right? I need a function that will give me the minimum index, right? It's going to be int min index. Is the minimum index in the array starting at from?
Zero. The first one from
Well, but if from is 27, then I just look at from 27 until the end of the array. I don't look at the first 26. Does that make sense? How do I do this?
Use for loop.
Use a for loop and a variable, right? What's my min IDX?
From.
Let's do. So I can call it min IDX. I start at from, right? And then for I equals what? Actually, from plus 1, because I don't really need from, right? ARR of I is less than ARR of min IDX. Ah! Then I'm missing return. Does this make sense? Might even work.
And what does the static do again? I already forgot.
Static means it belongs to the class, not to each instance. So you don't need an instance to call it. You don't need p.x. You can do point.x.
So in this case, it makes it more convenient.
Because I'm calling it from main, and I don't need an instance of array examples class. That's not going to be very useful, right? So let's do 2, 1, 7, 5, 4, 1, 2, 3. System.out.println minimum index of numbers starting from 0. What do I expect to get?
It's gonna be 1, 1, 2, 2, 3, 4.
It's going to be this guy, right? Which is index 1, right? If I start 0, 1, if I start from 2, I'm going to get this guy, which is index 0, 1, 2, 3, 4, 5, right? And if I start from index 6, I would expect index 6, right? No, this is the index, not the value. So I expected 1, 1, 6. Oh, wait a minute.
So it's not sorting. It just gives.
No, I'm not sorting yet, but my minimum index with 2 didn't work, right?
Is it using the value from the previous call?
No, let's see. This one, right? Should never be able to return less than from, right? So it cannot return a 1. Oh, I am an idiot. No, I used 1 instead of I.
Oh, I can see that because I need glasses.
And this is why you write unit tests. We'll talk about unit testing. I've been testing them like this. Okay, that makes sense, right? 1, 5, and 6. Life is good, right? Life is goodish. Right? So now, given this, we can do selection sort, right? Actually, there's one more. Static void swap. How do I swap the elements in places I1 and I2 in an array? I can do this, I1, did I do it? Does this work? Imagine that my array is 10, 20, right? I1 equals 0, I2 equals 1. Let's do it. ARR of 0 equals ARR of 1. So this becomes 20. Right? Now ARR of 1 equals ARR of 0, so this stays as 20. Did I swap?
Oh, okay. Oops. Yeah.
Oops.
You gotta create another variable.
I need a temporary variable to keep the first element. If not, I override it and I forget about it, right? So int temp equals ARR of I1. And here I do temp. Does that make sense? Probably even works. So now this would print 1, 2, right? Rather than 2, 1. So to run it prints 1, 5, and 6, and then 1, 2, 7, 5, 4, 1, 2, 3. Yay! So it reasonably works, right? So what does this do?
Now it has to do
Start at 0.
select how many times.
What I do is int min idx equals minimum index of this array starting at element number I, right? And then do swap arr I and min idx. With some luck, this actually sorts.
Did you make the for loop for how many times you need to do that?
Yes.
Oh, you did.
It's not just how many times. Each time, right, I'm doing it with a shorter array by passing I here, right?
Oh, so you're conveniently.
And the one that I'm swapping is now
You
the
don't
next
need to
element
add
in the
another, like, variable that you add to. You just use the I from the for loop.
yes. I'm shortening and shortening my array. So with some luck, this actually works. So I can do sort numbers, print array numbers. One, one, two, two, three, four, five, seven. Yay! This algorithm to me is super cool because it's very easy to understand. It's just calculating the minimum, right? And then it's one of the standard slow algorithms. How long does it take? Right? It's probably not a bad idea for us to start thinking about, yeah, right? How long does it take me to find the minimum element of an array?
Length of it,
Depends on what.
where it is.
Does it depend on where in the array is the element?
You gotta check all
I gotta check all of them. So what does it depend on?
Length.
The size of the array, right? If an array is size 1000, then it's gonna take me 1000-ish steps, right? Plus or minus 1 or something like that, right? So we call that linear growth. Your array grows linearly. Now, how about this? Selection sort. My outside loop takes, I do that how many times? And for the length of the array,
Length
right?
of the array,
Now, inside, what do I do? Well, I call this minimum index. How long does that minimum index take? Sorry?
Whatever hasn't been.
So,
also
the length-ish of the
yeah.
array.
Yeah.
Length of
Right.
array.
So what's happening is I'm doing the summation of, right, 1 to n, which is basically n squared over 2. It's not n squared over 2, it's n times n plus 1 over 2 or something like that. Does that make sense? We say this takes quadratic time. Quadratic-ish time. Does that idea make sense? Order of n squared. You will see that in data structures and algorithms, right? This is just to prime your brain for when you actually see it. Right? So this would take quadratic-ish time. There is a bunch of other ugly sorting algorithms that take quadratic time. There are a couple of much more complicated algorithms that take order of n log n, which is much better than quadratic. But you see those in data structures and in algorithms. Actually, there is one other algorithm that I want to see. We have seen one sorting algorithm. You can go find other sorts. Bubble sorts is very popular. It's actually works, but it's also quadratic. And then there is insertion sort, which is really weird, but it actually makes sense when it's what you use when you play cards. pick a new card and just insert it in the right place. Right? But there's another cool algorithm called binary search. Have you played high and low? Think of a number between 1 and 100, and I'm going to tell you whether you guess too high or too low. Yes?
Well, I'm not gonna guess 99. I'm gonna guess 50.
Okay. It's too low.
75.
It's too high.
Oh, then you do 25.
It's between 50 and 75.
Okay. 55.
Well, that's good laziness, right? It's like, I don't care, 55. But what's the right number to do? Why did they choose 50 and 75, right? And which one should you choose now? You choose the one in the middle, right? So 67 or something like that, right? Does that make sense? And each time you're removing the biggest possible, you're guaranteed to remove a big thing, right? As opposed to going 99, 98, right? Where you could get 100. If you do binary search, you're guaranteed to find it in how many tries? About, actually a lot less than 10.
It's
7.
going to be log of 10.
It's going to be log of 100, which is 7. Right? Logarithm base 2, right? Plus or minus 1.
Yeah, it's like 2 to the what is
2 to the what is equal to that number. So it's 100, right? 2 to the 7 is 128. You know all the parts of 2, right? It's probably not a bad idea when the professor is droning about stuff like now. Just do powers of 2 in your head, right? 2, 4, 8, 16, 32, right? You should basically have almost memorized up to 1,000, right? 2 to the 10 is 1,024. That's very convenient because that allows you to map between 10s and 2s, right? 2 to the 8, you would know it because it's a byte. 2 to the 8 is what? 256, right? And that's how many characters you can put in a byte, how many different values you can put in a byte. A byte has between 0 and 255, right? Those are the values for a byte. So you memorize those, and maybe you memorize some of the others, or almost memorize some of the others. But so what binary search does is converts linear search into logarithmic, which is amazingly cool, right? So if you're trying to do from 1 to 1,000, instead of 1,000, now you do only 10, right? Which is amazing. So let's implement binary search in an array. The number has to be, the array has to be sorted, right? So int
So we're looking for a particular value.
we are looking for a particular value, and what we want to return is the index. Let's call it target or something.
Well, what if there's more than one of that value in the array?
I don't care. Just give me one. Right? So how can we do this? Actually, first do it the right way. Yes. With recursion. Can I make this thing go away? Now we have low and high, right? Which are the indices, right? So if now I'm gonna do int middle equals low plus high divided by 2, right? Notice that if low plus high is odd, I'm doing one less, right? I'm doing 67 rather than 68. Does that make sense? Because that's going to be important.
We're doing a search on an array that we know is already sorted.
Yes.
Okay.
So we find the middle, low plus high over 2, and then we compare with the target, right? If it's equal to the target, what do we return? Well, middle. Right? The index. Oh, we have one more, right? If low is greater than high, return minus 1. Right? Which is not in there. If it's equal, return the middle. Else, right? If ARR of middle is greater than the target, now where are we going to search? We're going to search between low and middle minus 1. Else, well, middle plus 1. Because I already tested middle, right? There is no point. And high. I need to pass the target. Does this make sense? So now this one becomes just return, bin search, yeah. Might even work. So now this is the array 1, 1, 2, 2, 3, 4, 5, 7. We search for number 1 and we got 1, which is okay. Yes.
Can you go up?
This?
Yeah, so it's like, yeah, that. So like if it's greater than the target, it searches between the low, and say if like the middle's 50, it's like low with 49, it searches between that half. Or
Yes.
it's like 50 and the high number, whatever that is. And it keeps on going.
Yes. Yes. It would do 49 or 51. You need, the plus 1 is actually important because you need to make progress. If not, you can end up in an infinite loop, an infinite recursion. So you need to make sure that you always make progress. So 1, we got 1, which is okay. 7, 0, 1, 2, 3, 4, 5, 6, 7, which is okay. Then we searched for 5, so we get number 6, which is good. And then we search for 17, which is minus 1. Isn't this cool?
So why did the first search for number 1 come up with the
1 rather than 0? Because we don't care. We just, it's the one that we found.
But what's going on? What happened?
Okay.
It's looking between.
Looks between 0 and 0, 1, 2, 3, 4, 5, 6, 7. Right? We get 0 and 6. Low is 0, high is 6.
Okay.
Middle is 3. Right? Is it the 1 for 3? 3 is this.
Yeah.
Is it that one? No. It's lower, right? So we need to search in the lower half.
You're
So
not-
now I'm gonna search. Sorry.
You're looking to see, is it dot one? All right. So
Is it that one? No. Then is it? Then I need to search the lower half, right, of the range. So now I have 0 and 2 because I subtract 1 from that 3. So between 0 and 2, the middle is 1. So it says, oh, is it this one? Yes, yes, it is. So I don't need to keep going. If you wanted to find a particular one, then you would need to, oh, now let me go down, right? Now from
Right.
here, let me go down until I find the lowest one, or from here, let
And
me
some
go.
of the more complicated sorts, they use like some of the basic methods like swap, like they use that one, and some of the better sorts too.
But this is binary search. This is not sorting. This
Right.
assumes the array is sorted, but it doesn't sort.
Right.
When you have a chance, do it with a while loop. It's a lot harder than it looks. We're doing it with
Do
recursion.
binary search.
Yeah. It's actually not that bad. You can do it. It's just harder than it looks.
Is either one more efficient, the recursion versus the while? Or not really.
Depends on your language, your computer, the face of the moon. It's fall now, so maybe. Usually while loops will be more efficient, but compilers are good. If you have a good language and a good compiler, it should be equivalent. I don't think that Java is guaranteed to have a good compiler. So in Java, it may, basically the compiler will convert this to a while loop. But I still do it. I still do it the right way, right? And so it's a lot easier to think about it this way. It's not that bad, you can do it, but it's like, it's a lot uglier with a while loop.
Scroll down.
I have 7 more minutes to want to do bubble sort. Nah.
Isn't bubble sort the one that like compares to and then moves on to the other
Yeah.
and swaps?
Yeah, swaps all the time.
And how does it know it's fully done at the end?
Well, let's do bubble sort, right? So we had selection sort, now we are going to do bubble sort. Let's do bubble sort. And by the way, I normally cheat by writing sub-functions so you never see nested loops, because I hate nested loops. Functions are nice, right? So let's do static void do bubble. What we are going to do with bubbling, right? And again, we are going to have a from. What we're going to do is check, and if we're going to check an element with the next one, and if they are in reverse order, So if the next one is lower, I'm going to swap. Does that make sense? Now, after I go through all the array, what's going to happen? Actually, after I go through all the array, what's going to happen? The biggest element is going to end up at the end of my array, right? Because it's going to go through a bunch of swaps and it's going to leave stuff in the middle, right? But the biggest element is going to be at the end of my array. Does that make sense? So what I can do is not from, this is 2. So what I can do now is do it again with one less and one less and one less. Does that make sense? Because now I know that the biggest element is at the end of my array. So sorry, greater. Does this make sense?
So when you swap this time, oh, okay, you don't override.
Okay, 'cause every time you do it, it changes the array.
Changes the whole array, but right, also the biggest element ends up, the array becomes a little bit more sorted and the biggest element ends up at the end, right? So what am I going to do here? Let me do this. Print array. I'm printing just so we can see what's going on, right?
Oh, so you're shrinking the array from like the end of the array.
Exactly.
Okay. Because that's the one that has the correct value.
Yep.
Not the biggest thing.
So let's change this to bubble sort. Ah! Hate you autocomplete. Autocomplete the right way. You should know what the heck do I want. Let's skip all this. Let's hope that we didn't break stuff. We did break stuff. We tried a bigger one. So I'm going up instead of down, right?
This isn't going to keep.
Sorry, this is minus minus high. Sorry. Okay. So it prints, right? And then it's gonna swaps these two guys, right? Now one is here. So it's gonna make the array a little bit more sorted. Then it swaps, leaves this, swaps the 7 here, swaps again, swaps again, swaps again, swaps again. The 7 ends up here, right? But if you notice, below the original 7, it made things a little bit more sorted. So now 1 and 2 are sorted, right? So it goes again, goes here, 5 and 4, and it's going to swap them, 4 and 5. Then actually the 5 goes all the way here. So now I'm here. The array is slightly more sorted, right? So now it's going to go 1 and 2. It's going to swap this guy, swap again, and now the 4 ended up here. This is almost sorted. And then look what happens. After here, the last 3 lines are completely useless because the array is already sorted because I'm sorting a little bit in the middle, right? I'm sorting a little bit of stuff at the beginning of the array. Does that make sense? I end up doing extra work, but I can finish early if I know what I'm doing. Does that make sense? So what I can do is transform this into a Boolean. And so if I end up making a swap, I'm also gonna do swap equals true. And so in here, I end up returning swap. So now this guy is also gonna tell me whether it made a swap or not. Right? So in here, I can do Boolean swapped equals do bubble. Then if I didn't make any swaps, then I don't need to do any more, right? So I can just return. So if I was to run this, it would actually do the same stuff, but now without the extra lines at the end. Maybe. Oh, here was still swapping. No.
Is it swapping the ones back and forth, maybe?
No, right?
I think it was just if it's,
So in this one, it's still swapped, right? It took away one, but it should have taken away more. No. Shouldn't have three, it should have only two. I messed up somewhere. Do this. Anyway, that is the idea. I think I'm printing at the end here. I'm printing more stuff here. That's the extra one. Because it needs to go once without swapping, which is this way, right? I have to go once without swapping to realize that I'm done. That's good. Cool. So now you know two ways of sorting and binary search. And you have an assignment so you can do 100 examples of arrays, right? It was already due, right? You've done 100 examples of arrays already, right?
wait, which one was just
No,
due?
the turtle was just due. The array is due next week. Okay, never mind. And you will do 100 examples of arrays. I'm as confused as you are. Cool. I will see you guys eventually.